Good day, everyone. I'm Sir RG Layson, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about graphs and problems involving linear function. In graphing linear function can be done in any of the four methods. We've already discussed on how to find or how to use this linear equation. Now, first is using 2 points, using x-intercept and y-intercept, using the slope and y-intercept, and using a slope and a point. Using 2 points, in geometry, 2 points determine a line, thus 2 points are enough to graph a linear function. So we have here an example. Graph the linear function f of x is equals to x plus 4 using 2 of its points. So, step number 1, to determine 2 points on the graph, you may assign 2 values of x, then compute for your f of x or your y. Let us try to consider -4 and 3 as your value of x. Also, you can make a table of values for this one so that you can easily identify the value of x and you can put there also in your table of values your value of y's so that you can easily plot it later in step number 2. Let's try. So when x is equals to -4, we have f of x or your f of 4 is equals to, substitute the value of 4. So we have -4, we have -4 plus 4, we have 0. So that means your f of -4 is equals to 0. That means that your first given ordered pair is -4 and 0. Your x is -4 and your y is 0. Next, when x is equals to 3, so we have f of 3 is equals to 3 plus 4. So your f of 3 is equals to 7. This gives an ordered pair 3 and 7. When your x is 3, your y is 7. This implies that the graph will pass through the points -4 and 0 and 3 and 7. Now, we can plot the ordered pairs of -4 and 0 and 3 and 7, then you can draw a line that passes through these points. So when you make a Cartesian plane, where can we plot -4 and 0? So we have here along the x-axis, and then we have here 3 and 7, +3 and +7 in the first quadrant. Then you can connect it that passes through these points. So this is your graph for your f of x is equals to x plus 4, your linear function, or your graph for this linear function, f of x equals to x plus 4. Next, using x-intercept and y-intercepts, linear function can be graphed using x-intercept A and y-intercept B. Remember that the x-intercept of the linear function in the point of intersection between the graph and the x-axis is represented by the point A and 0. Meanwhile, the y-intercept of the linear function is the point of the intersection between the graph of the y-axis, thus represented by the point 0 and B. Now, how to find the x-intercept and the y-intercept? You just need, in finding x-intercept, you let y equals to 0. And finding also the y-intercept, you just need to let x is equals to 0. Let's try this example. Graph the function f of x is equals to 2x minus 6 using x and y intercepts. Step 1. We need to find the x and y intercept. Recall that in finding x-intercept, you need to let the f of x or y equals to 0. Meanwhile, in finding the y-intercept, you need to let x is equals to 0. That is, when you find x as intercept, you let f of x is equals to 0. So 0 is equals to 2x minus 6. Now, you need to add both sides by 6 by addition property of equality, or you can transpose it easily, the positive, your -6 to the left side. So it will now, 6 is equals to 2x. So you need to multiply both sides by 1/2, or you can divide both sides by 2. So we have 2x times 1/2, we have x or 1x, and then 6 times 1/2, we have 3. So in symmetric property of equality, so x is equals to 3. Thus, the x-intercept, when your x is equals to 3, your y is 0. This means that one of the points of the graph is 3 and 0. Now, let's find the y-intercept. So, how to find the y-intercept? You now need to let x is equals to 0. So, we have now f of 0 is equals to 2 times 0 minus 6. So, 2 times 0 is 0. 0 minus 6 is negative 6. So, thus, the y-intercept, if you have x is equals to 0, your y is negative 6. Hence, another point of the graph is 0 and negative 6. Then, plot the x and y intercept. Then, draw a line that passes through the intercepts. So, we have here 3 and 0. You can plot that one along the x-axis. And 0 and negative 6, plot that one along the y-axis. Then, connect or draw a line that passes through the intercepts. So, this is the graph of your linear function f of x is equals to 2x minus 6. So the third one is using the slope and y-intercept. The third method is by using the slope and y-intercept. So this can be done by identifying the slope and the y-intercept of the linear function. So we have here graph the function f of x is equals to 2x plus 1. Step number 1, we need to identify the slope and the y-intercept or the b. In function, the slope is, di ba? What is the slope-intercept form? Y is equals to mx plus b, where your m is the slope and your b is your y-intercept. So here, your slope is 2 and your y-intercept is positive 1. So first, you need to plot the y-intercept. So let's go back to your y-intercept. So what will be the point here when your y-intercept is equals to 1? So we have here, your point here is 0 and 1. So you will plot 0 and 1 in your Cartesian plane. So that is your y-intercept, 0 and y. So along the y-axis. Now next, step number 3, to find the other point using the slope, we need to remember that slope m is equals to rise over run, right? Which means that your slope is 2, so it can be written over, it can be written to 2 over 1. So that means your rise is 2, your run is 1. You need to remember, if you have a positive in rise, if you have a positive value of your rise, so you need to move upward. So if your rise is negative, so you need to move downward. So in the run also, if you have a positive value of your run, so that means you need to move to the right. Now, if you have a negative value of your run, you need to move to the left. Okay, some values to the left. So since we have here rise is positive 2, so that means we need to move 2 units upward since we have rise is equals to 2. And 1 unit to the right since we have run is equals to a positive 1. So first, focus ka sa imong first nga nimo nga point, which is si y-intercept, then move 2 places upward since our rise is 2. 1, 2. And then 1 unit to the right since our run is 1. So 1. So that means your point is here. So we have your next point is 1 and 3. Now, since you have 2 points now, you can connect the points passes through. You can draw a line that passes through your given 2 points now. Next, in using slope and 1 point, the fourth method is graphing linear function is by using the slope and 1 point. So this can be done by plotting first the given point, then finding the other point using the slope. So graph the linear function f of x is equals to negative 2x minus 3 using the slope and a point. So find first, step number 1, we need to find first the find the point from the function. You may assign any values of your x given in the function. Let's say that your x is equals to negative 1. Then compute f of negative 1. So we have f of negative 1 is equals to negative 2 times negative 1 minus 3. Negative 2 times negative 1, we have positive 2. Positive 2 minus 3, we have negative 1. So that means your f of negative 1 is equals to negative 1. So that means your point, thus the line passes through the point is, if your x is negative 1, your y is negative 1. So we have negative 1 and negative 1. So next, also in step number 1, you need to plot the point now. So negative 1 and negative 1 here in your third quadrant. Next, step number 2, find another point using the slope. So the slope of your given function is negative 2, right? So that means you can write that one into negative 2 over 1. Thus, your rise is negative 2 and your run is positive 1. So again, so since we have a rise of negative value, so that means you need to move 2 units downward. So your first point is negative 1 and negative 1. So move 2 places downward, 1, 2, and then move 1 unit to the right since your run is positive 1. So 1 unit. So we have here. So that means your point now is 0 and negative 3. Then you can connect, can make a line that passes through the 2 points now. So this are the 4 methods on how to graph linear functions. Now, for your activity, you need to answer, how do I look? So, for numbers 1 to 4, you need to sketch the graph of the given linear function using the indicated method. So, we have here the given equation, 1, 2, 3. The 4 is in the next slide. Methods to use. So, number 1, you will use 2 points. Number 2, slope and y-intercept. And then number 3, we have x-intercept and y-intercept. And you need also to graph your given linear function. And your 4 is f of x is equals to negative 3x plus 2. We need to use the method slope and 1 point. And in number 5, you need to determine the function that best describes the given graph. So here, the given graph, you need to write the linear function. You need to also to answer the guide questions. You need to answer this one in your notebook. So let's go now to related problems on linear function. So we have here, linear functions has varied application to real life situations, such as concept of rate of change and direction variation. So we have here an example. Fernand drives a motorcycle going back to his town. He traveled an average speed of 60 kilometers per hour. First, in A, we need to make a table that relates to the number of hours that he traveled x and the distance he covered in traveling of your f of x or your y. Letter B, we need to write the linear function that describes the best problem. Letter C, what would be the distance of the covered after traveling? What would be the distance he covered after traveling for 4 hours? Letter D, if his hometown is 330 kilometers away from his starting point, how many hours should he travel? And the last task is we need to sketch the graph that describes the function. So try to screenshot this one and let's review later each of the steps that we need to accomplish. First, in A, the table below relates to the number of hours, which is he traveled x, and the distance he covered in traveling your f of x. So, the number of hours, so since we have here 60 kilometers per hour, diba, it's stated there in the problem, that means in 1 hour, so he will be traveling 60 kilometers. In 2 hours, so he will be traveling, he traveled 120 kilometers. In 3 hours, he traveled 180 kilometers. So, you can state 3 kining points lang in your table. It can be it's acceptable already. So, in B, recall that concept in finding the linear equation using 2 points from the table considered. So we can use 1, you can pick 2 points lang class, 1 and 60 and 2 and 40 to the okay. Consider 160 to be the first point and 2 and 120 to be the second point. You will substitute this one in your linear equation given 2 points, which is minus y sub 1 is equals to y sub 2 minus y sub 1 over x sub 2 minus x sub 1 times your x minus x sub 1. So this will be your 1 is your x sub 1. Your 60 is your y sub 1. Your 2 is your x sub 2. And your 120 is your y sub 2. Okay. Substitute now. So we have here, since we don't have the copy y, then your y sub 1 is 60. So minus 60 equals your y sub 2 is 120 minus your y sub 1 is 60 over x sub 2 is 2 minus x sub 1 is 1 times x minus your x sub 1 is 1. So simplify. 120 minus 60, we have 62 minus 1, we have 1. So we have now y minus 60 equals to 60 over 1 times x minus 1. So we need to simplify, distribute. So 60 times x, 60x, 60 times negative 1, we have negative 60. So we have y minus 60 equals to 60x minus 60. Transpose negative 60 to the right side. So we have now y equals to 60x minus 60 plus 60. So negative 60 plus 60, we have 0. So that means your f of x is 60x now. Thus, the linear function that describes the situation is f of x is equals to 60x. To find the distance that traveled after 4 hours, you just need to substitute 4 to your x. So we have 60 times 4, we have 240 hours. 240 kilometers is your he traveled after 4 hours. Thus, the distance traveled by Fernand after 4 hours is 240 kilometers. To find the number of hours needed to travel to 330 kilometers, you need to substitute 330 kilometers to your f of x or your y. So 330 equals to 60x. Divide both sides by 60. So we have 60x divide 60, we have x. 330 divide 60, we have 5.5. Thus, Fernand should travel for 5.5 hours or 5 hours and 30 minutes to reach his town. And now, the graph below that describes the given problem. You just need to plot, in 1 hour, he traveled 60 kilometers. In 2 hours, he traveled 120 kilometers. In 3 hours, he traveled 180 kilometers. So, the graph is increasing. Now, you try to answer this one in your notebook. So, copy and answer. You just need to follow the process in how to solve problems involving linear function and try to answer the following guide questions or the guide task. Thank you so much for watching. I hope that you've learned something out of this lesson. Please don't forget to like and subscribe and share it with your graded friends. Thank you so much again. Goodbye.